So in this question we have methane and oxygen, and they're going to react to form carbon dioxide and water. And we're given the amounts of methane that we have and the amount of oxygen that we have. And those are going to be used up to produce the carbon dioxide and the water. And so the first thing I'm going to do is I'm going to write down the chemical reaction for this. And so this says we here that we got methane, and that's going to be CH4. And we have that combined with oxygen, so I'm going to put oxygen. And oxygen's diatomics was actually going to be O2 like this. And that's going to produce this carbon dioxide, so I'm going to put CO2. And then it's also going to produce water, so I'm going to put H2O down. And so what we need to do is balance this reaction. And so we can look here and see that I got two oxygen atoms on this side of the problem, and then I actually have two oxygens here, and I have one oxygen atom here. And so I'm actually going to have three oxygen atoms on this side, and I got two oxygens on this side. And so what I need to do is I need to add more oxygens to this side. And so what I can do is I can put a 2 right here, and so actually I can have four oxygens right here. So we have two of these molecules in here, and so that's going to be four oxygen atoms. And over here I now have three oxygen atoms, so now I have to add more oxygen atoms to this side. And so I need to add just one more oxygen atom. So I have these two different options. I can either add a whole new molecule of CO2 or a whole new molecule of H2O. And because I want to add one more oxygen, I'm actually going to add one more H2O molecule to this one. And so I have two oxygen atoms here, and then I have two oxygen atoms here. So together that's going to be four oxygen atoms on this side. So now that this reaction is now balanced, what I can do is I'm going to take what the problem gives me. I'm going to put that under the different chemicals. And so it says here that I got 3.2 grams of methane, and so I want to put 3.2 grams of methane here, and then I got 12.8 grams of oxygen, so I want to put 12.8 grams of this oxygen here, and then it says it's going to produce 8.8 grams of this carbon dioxide, and so I'm going to put 8.8 grams of carbon dioxide. And then what I want to figure out is how many grams of this H2O I'm going to have over here. And so what's going on in this reaction is we have these two chemicals right here are being used up, and they're going to produce this over here. Now we already know how much of this is going to be produced, but we need to know how much of this will be produced. And so what I'm going to do is I'm going to do this problem basically twice. I'm going to do it once for the CH4, and then I'm going to do it once for this O2 right here. And that's because this is a limiting reactant problem. Anytime you're given two different chemicals with two different amounts, you have to do the problem basically that number of times. So because I have two different chemicals and two different amounts of each of them, I'm going to have to do this problem basically twice. And so what I'm going to do first is go from grams to moles of each of them. And so we'll start with the CH4, the methane. And so I got 3.2 grams of this methane, and I'm going to divide it by the molar mass, which is 16. And so that's going to be 0.2 moles of CH4. And what I'll do is I'm going to go to grams or moles of H2O. And so what I'll do is I'm going to put CH4 on the bottom, and then we'll put H2O up top. And from looking at this balanced chemical reaction, I have a 2 right here for the H2O. So I'm going to put a 2 right here for the H2O. And for the methane, the CH4, I have a 1 right here. And so I'm going to put a 1 right there. And so I have 0.2 times 2 divided by 1. That's going to be 0.4 moles of H2O. So this is the maximum amount of H2O number of moles that I can make given 3.2 grams of this methane. And so now let's do it again for the oxygen right here. And so I have 12.8 grams of oxygen, and I'm going to divide that by the molar mass of oxygen. Now oxygen's got a molar mass of 16, just one of them, and because I have two of them, I'm going to have to do 16 times 2, so I'm going to get 32. And so I'm going to have 32 there, and when I divide those, I'm going to get I'll get 0.4 moles of oxygen like this. And so what I'll do now is I'm going to put oxygen on the bottom, and then I'll put the H2O up top. And this oxygen here will cancel with this oxygen here, just like this CH4 canceled with the CH4 there. And so because there's a 2 right here, I'm going to put the 2 right there. And then there's a 2 right here for the water, so I get a 2 right there for the water there. And so I have 0.4 times 2 divided by 2, so I'm going to get 0.4 moles of H2O. And so because both of these make the same number of moles of, of H2O, it means that both of these are going to run out at the exact same time. So I'll have none of this left over and none of this left over once this reaction is complete. And so what I'm going to do now is, I know that I'm going to have zero point 0.4 moles of oxygen. It's going to be produced. I need to go to grams. And that's one kind of an important idea whenever I set these problems up, is that I put the grams right here so that I know to go to grams and not leave this as moles. And so to go from a mole to a gram, I'm just going to do moles is the grams over the molar mass. And that's really the same thing that I did over here. I did the grams divided by the molar mass, and that's how I end up getting moles for both of these. And so we know we have 0.4 moles of this water, and that's going to equal the grams divided by the molar mass. And the molar mass of water is going to be 18. And so we're going to do 0.4 times 18, and we're going to get the amount in grams of this H2O right here. It's going to be 7.2 grams. And so this right here is going to be the answer. 7.2 grams of this water right here would actually end up being made.